Welcome to the demonstration corner. Today we'll be talking about the MTPS sensor available on our new MPV. We'll show a setup of a sample for bulk measurement, as well as the MTPS sensor comes with other modules to measure other types of sample dimensions, such as slab, anisotropic, and 1D. But before we do that, classic demonstration corner. We'll talk about what's in our demonstration corner for training and one-on-one demonstration. So down this side is the HFM 25 for small format insulation. So this is for measuring insulation of a couple inches in size. And we've designed this to follow ASTM C518. That's our HFM 25. Our MP2, which is our measurement platform 2, which is our portable version in our MP series. It uses primary sensors for TPS for solids, transient hot wire for liquids, and transient line source for measuring soil and polymer. This is our THW-L1, which is our focused instrument for measuring liquids and phase change materials according to ASTM 7896, thermal conductivity, thermal diffusivity, and specific heat. You can back pressure the test cell to test past boiling points. The overall temperature range, depending on configuration, is minus 160 to 300 Celsius with a back pressure up to 35 bar. So we'll skip the MPV and just come to the MP1. This is the industry leading platform for multiple transient methods. We've really combined the highest capability in the market, combining transient plane source, transient hot wire, transient line source, and transient hot strip, all of the basic transient methods in a marquee measurement platform system that enables you to take advantage of the multi-port capability. So there's 4 channels in the MP1, and our temperature platforms to measure a wide range of materials and really future-proof your thermal conductivity testing needs. And then coming to this side of the demonstration corner is our GHFM. So this is ASTM 30 for measuring complex materials. And by complex, I mean heterogeneous or non-repeating layers. So that would be if you had layers of materials that were on top of each other and non-repeating. This method measures thermal resistance, and it guards one-dimensional heat flow. So you're measuring a high confidence thermal resistance through the thickness of the sample. And that can be done over a temperature range of minus 20 to 310 Celsius. Actually, that's the plate temperature range. The mean temperature range would be based off the delta T that's on each side. So again, this is guarded heat flow meter following ASTM E1530. And then our other steady state device, which is our HFM 100, that's for measuring construction materials and insulation according to ASTM C518. We have 2 sizes of that, the HFM 50 and the HFM 100. I invite you to learn more about that in one of our other demonstration corners. So coming back to our MPV, again, we've designed this to be a mid-range instrument with integration of several technologies we have designed over many years to give us, a very powerful instrument at an economical price. So we've combined, the basic system comes with a configuration of sensors, transient plane source sensors, and bulk module and slab module for measuring conductive sheets, and transient hot wire under ambient conditions, both for thermal conductivity, thermal diffusivity, and volumetric specific heat for the transient plane source method, solids, pastes, and powders, and for the transient hot wire, liquids and phase change materials. That's our basic package. In addition to the basic package, you can add optional sensors, and we did a demonstration yesterday on a full description of what they are, but they are the MTPS sensor, the absolute version of that. What that means is from the output of the instrument, we auto-calculate thermal conductivity, thermal diffusivity, and specific heat for solids, pastes, and powders. We discussed that, and that sensor comes with several modules as a package that makes it able to measure bulk and directional properties. Transient hot wire for testing under pressure. So the included transient hot wires for ambient pressure. The upgrade sensor that you can purchase with your MPV, it allows you to test up to 100 degrees under 20 bar, which is for testing up to boiling points and past boiling points. And then the last sensor we offer is the transient line source following ASTM 5334, the new 22A standard, in ASTM 5930 for testing soil and polymers. So what we're going to talk a little bit today is specifically on sample setup for bulk and slab on the MTPS sensor, and show you a quick measurement and some raw data and calculated results on that. So if we bring the camera in. So I might get on the other side of the sample and make it a little easier for me to show that. So this is the bulk sample. We'll be showing basic setup, but on the experiment we'll actually be demonstrating an experiment of asymmetric on a piece of material that we would describe as slab. What is a slab sample? A slab sample is a material that's less than a few millimeters in thickness, but conductive. And conductive, the range would be 0.1 to 100 watts per meter Kelvin, depending on your configuration, or up to 500 watts per meter Kelvin. So that's the two ranges you can acquire with the MPV. The basic is 0.01 to 100, and the upgraded or max TC is up to 500 watts per meter Kelvin. So those are the two configurations we'll talk about. The MTPS sensor, it comes with the ability to test in this mode. So sensor facing up, that's just a protective covering we place on the sensor, or sample facing down. But in our demonstration today, we'll just be showing standard laboratory testing, sensor facing up. This is the cradle that comes with the sensor. As I mentioned in yesterday's video, it comes with a vibration dampening silicone pad, and that lets you have a nice convenient platform, so when you set it up it doesn't move around on you. It's got lots of weight. From here you can test the sample with the included 1 kilogram weight like this. Again, this is absolute, so we need no contact agent or factory or user calibration. It's absolute. So that allows you to pick test times to penetrate into your sample based off the dimensions of your sample. And that's basic ideal theory of the transient plane source method. And we talked more about that. Yesterday we did quite an elaborate description of the assembly and the description of how this is made and how that fits in with what I describe as following the ideal theory, so that we have a very good sensor that allows us to measure a wide range of materials such as solids, pastes, and powders. The configuration for slab, so again that would be a conductive material that's ideally less than 5 or 6 millimeters thick. You place it on top, and this is a asymmetric or single-sided configuration. And what we do to isolate the thickness is we introduce an insulation. That insulation is placed on top of the slab sample. And just like following the ISO for transient plane source 22007-2, it follows the same principle. It's just we're the only ones that developed the ability to measure asymmetric slab. And to allow that, basically the theory for slab is we isolate the thickness. We do record the thickness of that slab sample, and we'll use that in the software, as well as we record the overall diameter or radius. We'll use that in the software. And then the ITPS will give us all the parameters needed to make measurement. So in this configuration, we could use a weight, or we could use the clamp that is included with the cradle. What does the clamp give us? The clamp gives us a high confidence contact. This stainless steel is not it's not compressible, so I'm not concerned about compressing the sample with finger tightening or weight. So that's your slab setup, asymmetric. The bulk sample would be exactly the same, just wouldn't need that insulation because we're working off a semi-infinite body in all directions, so we're measuring three-dimensional. The other capabilities of this that are included with the sensor are bulk, slab, one-dimensional, which measures along the length of a rod, and anisotropic. So in anisotropic, the module would be used for detecting differences in conductivity through thickness and in plane, and would give you the results for those. So it's quite a powerful sensor and package of modules. This version of the sensor is good to 200 Celsius. We have a 100 degree version as well. So there's a 100 degree and a 200 degree Celsius temperature range option. Otherwise, all the other components are identical. So we're going to go to the software now and show basic setup of that. So So we ran a measurement of Teflon that I'll show you the results on. We did finish 3 measurements and we canceled the last 2. We ran out of time before the demonstration. We'll show you the 3 that we did measure. So this is from our general window. Again, we've separated for the MPV and the MP1. We separated the software out into 2 applications. Data acquisition, which lets us schedule measurements across different sensor types, different methods, and with the MP1 across multiple channel. Now the MPV has 1 channel, so you're plugging 1 sensor at a time, which allows you to run at room temperature or automate it with temperature depending on your accessories. And it still has all the capability of the same MP1 software, just lacking some of the scheduling capability because of the multi-port channel on the MP1. So here we would have the name of the user. We would point to the location we want the data stored. We would select the modified 3D disk source, and we're going to do not a semi-infinite body. That would be if your sample was bulk, meaning penetration depth in all directions equal to a certain amount, a minimum. We're going to measure slab, which would be for a thin sample in the range of 0.1 to 100 watts per Kelvin or 500 watts per Kelvin, depending on your sample type. So we go to the next screen. Auto identifies the MPV as what's plugged in. We're going to use the room temperature sensor. That would be the MTPS. We don't have anything plugged in for measuring temp, or rather recording these properties with temperature. We go to next. Here's where we can name the sample. Stainless steel. We'll put the sample thickness and the radius, which I believe is 20 millimeters. We'd select the sensor port. That's the MTPS. The sensor model is 33171. That's the diameter, so it's 6.4 millimeters radius. Check the resistance. That confirms that the sensor is functional and not damaged. Here is where we would run the ITPS, and what that does, it's a continuous measurement where the sensor is looking for the edge of the sample. Again, in slab mode, our semi-infinite body is in the in-plane direction. So it knows the radius of the sample, and it knows the diffusivity based off the measurement it would take. So it's looking at the time and diffusivity of the sample to identify a test time and suggest that to the user. That's about a 2-minute measurement. That automates all the parameters necessary to follow the ideal theory on the transient plane source, or the modification being asymmetric single-sided. We've already run that, so we know what they are. That's approximately 1,000 milliwatts for 5 seconds, and that's the test time needed to stay within the semi-infinite body radially. So that's the distance from the edge of the sensor to the edge of the sample in slab mode. And so from here, we can set up a schedule of, let's say, 5 tests with a 10-minute delay and 1,000 milliwatts, and start that measurement. And that automatically goes into measure the sensor resistance, do that first 10-minute delay, and make the measurements. So here we can see the schedule before it that we canceled. It was scheduled to make 5 runs, and it completed 1, 2, 3. And we can review that here. So you can see we have the thermal conductivity, the transient of temperature rise versus time, and the residuals. We can review that, and we prefer to review that in the full analysis so that we can see all the data. So this is the secondary application, which is the transient analysis application. So this allows you to install it on the computer that is driving the instrument, sure, but you can also install this application on any computer that you want to use to look at your data. From here we can export data, review it fully, apply different calculations, and really review your data. So this is, of this piece of Teflon, this is the thermal conductivity, diffusivity, and volumetric specific heat, measured 3 times, and you can see the test time that was suggested from the ITPS, 40 seconds and 75 milliwatts. So you can see the average and the repeatability for measurement of Teflon. So we probably won't take the time to let the slab finish, but certainly we'll cover that in another demonstration where you can see the results of asymmetric slab on stainless steel. That is scheduled to run now. Certainly, and this is the central spot that you'll see all the initial data record it as the MPV proceeds through the schedule. So we certainly have lots of slab asymmetric data from the MTPS sensor in application notes or for review. So if you want to see some data or a demonstration on your own material, reach out to us and we can arrange that. So I think that concludes the introduction of the MTPS sensor for bulk and slab, and some of the strengths of that sensor and the power it brings to the single-sided testing or asymmetric testing market for the mid-range MPV. Thanks very much, and if you have any questions, please reach out to us.